Hi students, today we're going to learn how to write quadratic equations when you are given either solutions or and or vertex or another point on the graph. Okay, so we're going to be talking about multiple forms of quadratic equations and how to write them using the information that we're given. Okay, so here are your expectations. Okay, you're supposed to know how to write a quadratic equation using the vertex form and write it in standard form as well. Okay, and write quadratic equation when you are also given the solutions or the graph. Okay, so we're going to be looking at all of those examples today. So let's talk about the three forms that we have. Okay, we have standard form, which is the standard way of writing a quadratic equations, where you have y equals 8x squared plus bx plus c. We have seen these before. Okay, we also have the vertex form, which is y equals to a times x minus h square plus k. And it is called the vertex form because it actually gives you the vertex, where h and k is the vertex. And then lastly, we have the intercept form. Now, this form sometimes is also called the factor form because, as you can see, those are the factors, the x minus p and the x minus q. Your p and q are the actual x-intercepts, or better known as the solutions to the equation. Okay, so let's take a look at examples for each of these forms. So here's an example of what a standard form looks like, right? And the standard form give us the ABC values, and we can use these ABC values to find things like the axis of symmetry, the maximum, the minimum, and the vertex. And we could also use the ABC values to find the solutions later using quadratic formula, which we haven't even talked about yet. The vertex form, here's an example of the vertex form, right? The vertex form give us the vertex at h and k, like I mentioned before. And it also gives us the axis of symmetry and the maximum because these two values come from the vertex. H is your axis of symmetry and K is either your maximum or your minimum. Okay. Finally, this is called the intercept form or the factor form. Okay. The factor form gives you the x-intercepts or the solution, right? The solution here is 4 and negative 2. So let's take a look at our first example. Here it says write a quadratic equation that has roots of -6 and -2 and the leading coefficient of 4. Now the leading coefficient is your a value. Okay, so in this problem they give it to you. And remember the roots also mean x-intercepts, right? So because it is x-intercept, we are going to use the intercept form to start with, right? So we're gonna first write the form with our missing values, and then we're going to try to find these values if it's not given to us. Well, in this problem, they did give us the 4 for A, and the two roots would be your P and your Q, right? Now, it doesn't matter which number you use for P and which number you use for Q, as long as one comes before the other. And now we're going to substitute the values in, right? Now notice there is a minus in the form and then the negative in the value. So you have to put both of them in, and then you're going to simplify that to get x plus 6 and then x plus 2. Now, if the problem only asked you to write in factor form, you would be finished here, right? But for the sake of learning, we're going to go ahead and use this and write it in standard form. To do that, we are going to multiply, right? We're going to multiply the binomial x plus 6 and x plus 4, and we're going to get x squared plus 8x plus 12. If you need a review on how to multiply that, you need to look at the previous lessons, okay? And then finally, one last step is we're going to distribute the 4 in front through, and then that is our standard form, okay? 4x squared plus 32x plus 48. Next example, we're going to look at one that give us the roots of -1 and 2 and a y-intercept. So in this problem, it's not giving us the a value. It's giving us the roots and a point on the graph. And this point happened to be the y-intercept. So Which form do we start with? Well, because they give us the roots, we should start with the intercept form because the x-intercepts are the roots, right? So write the form. Now we're going to substitute values in. But this is a little different, right? We know our P, we know our Q, but we do not know our A. However, we do know our X and Y. And we're going to take advantage of the y-intercept so that we could actually solve for a, because we need the a value, okay? So we substitute values in, okay, with the a missing because we don't know what it is, okay? And then we're going to simplify this, right? We have -4 equals to a times 0 minus a -1 times 0 minus 2. So we're going to take care of the parentheses first. We simplify the first parentheses, we get a 1. We simplify the second parenthesis, we get a -2. And then we multiply all of that together. We get 1 times -2 is -2, and then times a is -2a. And then that equals to 4. And then we use a one-step equation to solve for a, which we divide by -2 on both sides. And we get -4 divided by -2 give us 2. So our a value is 2. Now that we have our a value, you can substitute it into the original form and simplify this like we did before, and we get this in factor form, right? So we got the factor form. Now we have to multiply this through and put this in standard form. So we multiply the x plus 1 and the x minus 2 together first, and we get x squared minus x minus 2. And then we multiply the 2 through to get our final standard form, our final answer, okay? So this is an example when they give you a root and a point with no a value. You have to find the a value. Next, we're given a graph, okay? So we have to extract as much information out of the graph as possible, right? So in this graph, they give us apparently 2 x-intercepts, one at -3 and one at 3. And then we have to have either a point or the a value. Here, we don't really have an a value because you can't really tell what the a value is from a graph. But you can tell where the y-intercept is. In this case, it is -12. So we're going to use this information and pretty much repeat what we just did on the last example, okay? We're going to pick the intercept form again, and we're going to start substituting values in, okay? So -12 equals to a times 0 minus -3 times 0 minus 3. So I'm just putting the x-intercepts inside the form, and I'm going to simplify the inside parentheses, and then I'm going to multiply, and then I will solve for a by dividing both sides by -9, and I simplify that answer to get 4/3. So my a value is a fraction, 4/3, which is okay. Now I put it in factor form, right? I have a times x plus 3 and x minus 3. Then I'm going to multiply everything together. Okay, so I multiply x plus 3, x minus 3 to give me x squared minus 9. The middle terms actually cancel out. And then I multiply one last time to get my standard form. Okay, now this standard form is a little different because it doesn't have the b term. The b term got canceled out, right? So you just have ax squared plus c, which is okay. All right, next example. This one gives us a vertex and a point, okay? So no roots, just vertex and a point. So what do we do? Well, because we have no roots, we shouldn't pick the intercept form, right? We need roots. So we have to pick the vertex form because they give us the vertex, okay? Obvious, right? So now you start with the vertex form, okay? Now remember, h and k is the vertex, right? So in this problem, h would be -6 and k would be -4. Now the point would be your x and y again, right? So we substitute this in so that we can solve for a. The a value is not given to us. So let's substitute everything in. All right, follow your form and put your signs in correctly, okay? And then simplify the inside parentheses. So -2 plus 6 would give you 4, and then 4 squared minus 4. Now, you got to take care of the exponent first. So 4 squared is 16, so you'll have 12 equals 16a minus 4. Now this become a two-step equation. So solve this two-step equation by moving the -4 to the other side by adding 4 to 12 to get 16, and then divide it by 16 to get a equals to 1. Now that you have the a value, go back to your vertex form and substitute that a value in. And then we're going to have to simplify this to put it in standard form. So to put this in standard form, you multiply the x plus 6 times x plus 6 first. The 1 in front, you can sort of forget that, right? But the 1 times anything doesn't make any difference. So you can just drop that 1, sort of say. And then multiply x plus 6 times x plus 6. And then combine the 36 and the -4 to get positive 32. So your final standard form is y equal x squared plus 12x plus 32. So I hope this has been informative. If you have any questions, attend my tutorials and look for more examples in my other videos. Thank you for watching, guys. Hope to see you next time. Bye-bye.